Hello everyone, I'm Anisha Dhillon, B21276. Our group project is about making a model that detects human activity using cell phone data. This is the overview of what will be discussed in the further slides. This is the problem statement. We have to make a two-tier supervised machine learning model that works on data fetched by gyroscope and accelerometer to detect the type of activity the person is doing.
Hello, my name is Shalini and my roll number is B21130.
So, as explained by Anisha and Radhika, our main project aim of this project was to predict the human activity from mobile data. Here, we had mainly 9 different fields for input from the gyroscope and accelerometer values, and it will classify our activity into 13 different categories. This is basically a two-tier model, which it will first classify into basic three main categories: fall, active, and ascension, and further it will divide into subgroups under each of these categories. For example, under fall, it will categorize into forward lying falling, forward knee lying falling, sideward lying falling, or back sitting chair falling. The first step in our project was to transform the data frame according to our own needs. As we did not require the column fall, I introduced a new column called activity, which will show 0 for fall data, 1 for active, and 2 for ascension based on the labels of the activities. Further, after we had got the activity column, I dropped the column called fault and the label as we did not require it further. With our modified data, first of all, I performed normalization on the training data set, then applied the K-NN method for classification into the three basic categories: fall, active, and ascension-descension. Trying out different values for K and measuring the accuracy and confusion matrix, I observed that our model showed maximum accuracy for K for the value of K said to be 10. This was the Tier 1 model of our project. I would like Jigyasa to further elaborate on the other methods used in this model.
Hello, I'm Jigyasa, and my roll number is B21195, and I'll be explaining the work that we did with PCA. So, principal component analysis, PCA for short, is one of the popular and effective methods of lossy dimensionality reduction. Here we have used PCA to obtain uncorrelated, reduced dimensional representation of data. Initially, we began by using the data obtained after data cleaning and KNN application for PCA. We started with principal components equal to 2, and then we went on for 3 principal components. Here you can see the graphs are plotted for both. The initial graph is for PCA2, and the variance of each component is explained, and the other one is for PCA, the principal components equal to 3. As we can see here, the total variance explained by each of the components, the total variance explained by them is 94.3. That's a better result. With PCA, the number of components taken as 3. So we have chosen the number of principal components as 3. Now I would like Radhika to explain further.
Hi, Anisha again. As the accuracy when KNN was applied to classify the test data into fall, active, and ascension-descension was quite good, we decided to use KNN algorithm to further divide the test data into subcategories. For example, once we know that the person is doing fall activity, we had to decide if he was forward lying or backward lying, etc. Now over to Radhika.
Hello, I am Radhika Gupta, B21314. Now, for that, we first created 3 data frames containing activity of only fall or active or ascension descension respectively, which were further divided into training and testing dataset. Now the training dataset of each category is made fit into the KNN classifier. It predicted the activity and correspondingly the accuracy was calculated. The first one, here's the first one. The first one we calculated for the fall dataset. We did for k equals to 1, 3, and 5, and the highest accuracy was observed to be approximately 0.529. And for the active data set, the highest was observed to be 0.789, and for the ascension descension one, it was observed to be 0.8988. The accuracy of all the subcategories was low, and therefore we decided to use another classifying algorithm, that is random forest algorithm. Over to Ayush.
Hello guys, my name is Ayush Gupta. My roll number is B21184. Now, since we saw that in KNN our accuracy was very less, now we use random forest method. So basically, what random forest uses the idea of a decision tree. Now, in decision tree, we have decision nodes and leaf nodes. In a decision node, we basically use different attributes of the data to classify it into classifiers. For example, if we have its attributes as x1, x2, and x3, so decision node can contain like a value like if x1 is less than 0.5, your value your x will belong to this class or something like that. So this makes decision nodes, and long leaf nodes is basically your classifiers. So now random forest method use these decision trees to classify the data. We randomly select k data points from a training data set, and we also select m attributes for classification. Now we build a decision tree associated with these k data points and m attributes. Now we do this process n times. So basically we make n decision trees, and now for whenever a new data point arrives, we find predictions according to each random tree, and we get a class. So we assign the class which get majority vote. So now, as we can see, upon using random forest method, your accuracy increases a lot. Now over to Satyam for all the ML integration and website generation process.
So hello guys, I am Satyam Patil, roll number B21223, and I am explaining the web application part of our project. So basically, I have used Flask to develop an HTML page on Python. So what Flask basically do is that it integrates HTML pages with Python. So basically, we can make an HTML page with the help of Python using Flask. So like we have to make some templates in which we have to make our all project files, web application files basically. So like after making them in file, we have to in Python file we have to just import Flask, and like we have to import all necessary attributes from form, which is basically one tag of website. So using post method, we can basically integrate all the attributes from our web page to directly to Python, and we can process our models on them. So basically I have built the Flask file. I used pickle library to import models. So what pickle library basically do is it can store pre-trained model. So we first of all trained our models, and then we stored them in a pickle file, and then we loaded them in our main app.py file. So after doing all this stuff and writing code, after running app.py, such rectangle gets open, and it will have one link which is actually URL link of our website. After clicking on that URL, such front end gets opened. So basically it's our website, human activity detector. It is basically clear from name that it detects what human do using our cell phone. So like how can we do it? Basically our phone has some data which is basically transmitted by gyroscope. So gyroscope is a small device which is present in every phone, and basically when we tilt our phone, and automatically the portrait video gets converted to landscape, it's because of gyroscope. So that gyroscope has many attributes in it, so that all data can be transferred to website, but for now we are manually putting the data. So basically when we put the data and run test it, such type of second page gets open. So this is our solution page. Basically this solution page have two lines. The first line will show you how we have classified in three classes. So our three classes was active, ascending, descending, and fall. So our first line is basically telling us in which class it is. So one model is developed for it, and one model is trained for it, and it will show you how we can detect if the person is in active, fall, or ascending descending. Now after classification of active, ascending, descending and fall, we have to sub classify this stuff. So for sub classification we have trained three other models, one for active, one for ascending descending and one for fall. So now because the person is in active mode, the active mode model will run and it will then classify it in four different classes. So it will basically give us in which class it is. So now the person is in active mode and the active mode is trending. So that's it from my side, and I will now hand over to Anisha to explain the video demonstration.
Okay, so this file is already uploaded on GitHub. Here we have a Python source file. We, by the name of app, we open it in Spider and we run the code. Upon running the code, a link is generated. This link, we open it in the web browser. We put the input values. These values are the values taken from gyroscope and accelerometer. And then we hit the test it button. We are directed to another page which shows the output based on our inputs. In this particular case, the person is in fall mode and is forward lying. Now, coming to the application of our project, this project can be further improved to make an app that uses sensors in our Android devices to detect fall and summon help by an alarm. The person will have 45 seconds to signal that they are okay, otherwise, it alerts the emergency contacts via call, email, or text.